All right, so let's get right to it. So the first thing again is the longest span. We need to figure out what the longest span is in order to understand how much weight to be able to put on it. Remember, the longest span is your weakest link, okay? So the longer the pipe, the less weight it can hold. So this is what we're trying to figure out using the new tool, which is the single point capacity tool, right? So here we can have the known length, right? It's all about how much information you have in order to be able to safely build, okay? So the more information you have, the better off you are, okay? So square pipe, 1 millimeter, 2 millimeter, and then the stainless steel is the options that we have available. So for example, length 48 inches, I press enter, and then I can see that I can hold 191.70 pounds on this particular length, okay? When I'm looking at an example like this, so if this is my length, I need to figure whether or not I can maybe shorten this length in order to be able to add more weight, or is this length okay for the amount of weight that I'm using, okay? That's kind of the basic 1, 2, 3 of that, all right? So if we look at some of the structures, we need to understand what happens when we put a good amount of weight on the structure. So for instance, when we're looking at identifying the longest span, a good idea of what may happen is that, for instance, at such a long length here, it's very, very likely that those two pipes are going to begin to deflect and bend down on us. So we need to figure if the amount of weight that is going on top is okay for the two spans, or do we need to add more support? So for instance, let's say I have 300 pounds that I want to put on top of that first, this first level here, right? We're going to be feeding boxes. Eventually, it's going to get up to 300 pounds. So first thing I want to do is open up my component attributes. I'm just going to click here to see whether or not that is possible. So right now I can see that the length here is 91.937. So if I type in 91.937 and I type in and I press enter, we can see that I can hold 100 pounds. All right, so let's go back to that and see what that means. That means that right now I'm able to hold 100 and 200. So right now I can hold 200 pounds in this particular setup. But again, we're talking about holding 300 pounds, so it's not going to be enough. It's not adequate enough for me, okay? So what do I mean? That means that I got to think about something. So my next thought is, do I have the space to add another section? And by doing so, we now have basically shorter spans to hold that particular amount of weight. So at this case, now I need to check what the length of this one is. And this is 44.5, okay? So 44.5, so let's look at what just happened, right? We grabbed the long span and we divided it in half so that now we have 44.5. So let's go here and type in 44.5, and then we can see that we have 206.78 pounds that we can hold in this particular length, okay? So what does that mean? That means that my original idea, my original thought was that I wanted to hold in this top section here 300 pounds. So now that I know that, I can basically grab the 44.5, which is, let's type it in here, 44.5, and we can see that we can hold 200 pounds, all right? So if we go back to that structure, and remember, we're still dealing with 300 pounds that we want to put on top of that, okay? So now we're going to divide 300 pounds, and we're going to divide that into, let's see, 1, we have 2, 3, and 4. All right, so let's look at this, 300 divided by 4, and we get 75 pounds. So essentially, each one of these will be able to hold 75 pounds. And then we are definitely sure that 44.5 can hold 75 pounds, right? Okay, so we're definitely well beyond what is accepted. If we look here, remember 44.5, the maximum is 206 pounds, and we basically need a 75 pound weight load for each one of these sections here. Okay, so in this scenario, we checked in okay. It's just more or less now, what are we thinking? Okay, so what if there is 300 pounds on this one? What if there is 300 pounds on the second, on the third, and on the fourth? Okay, so that is 3, 6, 9, 12, right? So now we're talking about 1,200 pounds in total. So that is a lot more weight than just the 300. So what does that do to the overall structure? Again, if we have a good amount of weight, chances are that the structure, if it's a mobile structure, is going to want to move from left to right. So one of the things that we can think about there is maybe adding lateral movement in order to be able to, again, create some kind of bracing to prevent it from wanting to move left to right, such as the case here. This is an example, right? We're using a short, tight angle here in order to keep those two from wanting to move away from each other, okay? That is one thought. Another thought is also to think about what happens to that weight front to back, okay? So that weight now, if we wanted to move it, there's a good chance that it's gonna wanna move the structure left to right with a good amount of weight, okay? So again, we're using diagonal support. So we're using a pipe in the middle along with the diagonals here to be able to go ahead and basically prevent that from wanting to move back and forth. And then if we have a closer look here, we also added a pipe in the middle, which can only, again, re-emphasize what we already know to be true, is that the structure itself is going to be able to hold that amount of weight. Now, the final thought is, can all of this weight be handled by the casters in which I am using in this particular scenario? Okay, so that is really what we need to understand. In this case, yes, right, we have casters that can hold 500 pounds each. So we have 1, 2, 3, 4, 5, 6 casters. So yes, we can hold that amount of weight. Another option here would be to maybe think about using the bottom base here, and instead of using the standard tubing, right? So right now, the pipe that we have here is the 1 millimeter. So perhaps if we look at that dimension, again, right, 91.37, and then we have smaller ones here as well that are going to also have a good amount of weight to carry. So let's look, same thing, right? 44.5. So let's just have a look here and see what 44.5 can hold on the 96 and then what it can hold on the 2 millimeter pipe. So 44.5. So basically we can hold 370 pounds on that 44.5, right? So let's go back. So 374, 1, 2, 3, 4. So 374 times 4 gives us 1,496 pounds, okay? So we can hold the amount of weight that we need to. Maybe as a matter of perhaps changing that bottom part, that bottom section here of this particular structure here. Let's look, let's zoom out. So again, is maybe do we need to consider adding the 2 millimeter base in order to strengthen the overall integrity of the cart, okay? Things to think about there, all right? Let's go ahead to another example that can be commonly seen oftentimes. Again, this is the supermarket rack that we have here. It's been about 10 years and it's still here, hasn't moved an inch. Again, it's a stationary, it's got diagonal support, and it's basically not going anywhere anytime soon. So for us, each one of these holds about 30 pounds. Each box can hold about 30 pounds on average. So we have three separate sections in this one here. Again, 360 pounds, 240 pounds on the first layer. Again, right, it's a good amount of weight, so we need to figure out how to distribute that. So in this case, we're using the longest spans, and we have 3 of which that we need to basically work with, okay? So 3 spans, and again, simultaneously using the component attributes from the window here. So we can see that 3.75. So 3.75, I have a total here of 360 pounds, which I need to account for. So again, I'm going to come to the calculator, because what I want to do is basically figure out how much I need to divide, right? So let's go back. Let's look at this here. Right, 360 pounds. I want to divide that into 3 spans, right? I have 3 total spans in which I want to hold that amount of weight. So here we go. 360 divided by 3 gives me 120 pounds. Okay, so if I go back, I understand that I'm well beyond what I'm capable of doing, right? So here I can put 120 pounds. And actually, let's go back just to make sure that that's the right dimension. Let's go back here. This dimension here, I believe it's 37 3/4, right? 37 3/4. Okay, so 37.75, 120 pounds, accepted. Okay, so in this case, the thought process, what I'm doing here is, can I hold 360 pounds on 3 lengths of pipe? The answer is yes, I can. Okay, so if I look at it and we just go over what we just did, is that we divided 360 pounds by 3, which is the number of spans that we have, gives me 120. So again, if I typed in my length, or rather my weight in this case, 120, I get to know, or I get the accepting green light. All right, so that's good for that one there. Okay. Same thing. So let's see, what does that mean on the bottom? On the bottom, again, we have a total weight of 5,460 pounds. All right, so that is a good amount of weight. If I'm looking at the bottom total weight, 540 is the main section here, which I want to make sure that I can hold. So again, I look at that long 37 3/4, and I divide that, or rather, I divide 540 into 3 spans, right? So 540 divided by 3, 180. So if I go back to here, I know, let's type in 180, and again, we have the go green light for that one. Okay, so that's how we utilize that single point capacity in order to understand how much weight we are capable of holding in any given structure. Again, the more information you have, the better off you have. So sometimes if we think about the different types of situations, we need to think if we have a particular footprint that we're restricted to. So therefore, because of a certain dimension, we need to figure out how to utilize or how to reinforce the structure with maybe angles. Maybe we don't have the space to add support, so we need to think about maybe adding angles instead. Okay, so those are the type of situations in which you need to ask yourself how much footprint I have and how much can I get away with within that particular amount of space. All right, let's look at another example here. Again, this is a forklift pallet cart. So we have a forklift, again, just going to be placing different kinds of weights. Example, 1,500 pounds, up to 1,500 pounds, for this particular situation here. What do I need to think about is basically, is it a good idea? Is it an option to think about adding square pipe in this situation? Okay, so maybe not a bad idea if we're dealing with a pallet cart in which, again, is getting beat up, it's getting bounced around, gets used a lot. So maybe the square pipe might be the option for this particular one here. So if we look at the dimension of the square pipe here, let's just drag it down and let's just get a quick measurement to see here, what do we have? We have 44 1/4. So at 44 1/4, let's look at what the square pipe looks like, 44.5. So 1,138.44 pounds is what we can hold in that particular pipe, which is a ridiculous amount of weight. So that means that I can hold well over 2,000 pounds just on those 2 pipes. But most importantly is, can the rest of my structure also hold 2,000 pounds? So this is what we need to look at now, okay? So in this case, we are using a surface that is getting basically, let's look at this from the side here. So we have a surface that is going to be getting fixed to the Flexpipe section of this structure. And then we can see that that Flexpipe structure or section is exactly right on top of the connectors for the square pipe. So there is no play there, right? That's all one solid compact piece there that is working together. All right, so we're very, very solid in that sense there. So now my question is, how much can these little spans hold, right? This is my main emphasis is, can my longest span do what it needed to do? So let's look at this dimension. Component 22.21, so just under 22 and a quarter. So let's go ahead and write here 20, well, this is what? This is a regular pipe, 22.25. So we can hold just over 400 pounds. So imagine 413. So 413 times 4, 1,652 pounds is the exact amount of weight. So if we go back to that structure we're dealing with, which is the one over here, then yes, we are more than capable of carrying those 1,500 pounds. Okay, so now in this situation, I guess things that I would look to think about is this surface here is going to basically distribute that weight throughout your structure, right? It's not going to be just on one particular point. So that's something to think about. Also, something that I want to mention here is the handles here, right? So we can see here that we've added an angle on the front part, and we've connected it to the actual structure here. Okay, so that's, think of like when you're holding a flag, right? If you're holding a flag on 2 points, it's going to be very easy for that flag to move. But if you hold it in 2 separate points, you're going to have a more stable hold of that particular flag. So that's what we're doing with handles. If you can have more than one point to fix it to in order to be able to have a good solid basically triangle in this situation here, in order to be able to have a solid handle to be able to push all that amount of weight. Another thing that you may want to consider if you're dealing with heavy weight as well is to think about perhaps maybe offsetting your casters so that you can go ahead and get a little bit more play when it comes time to spinning this structure around, right? So basically, when it comes time to pivoting this structure, you're going to have a better time doing so if there's a lot of weight, if you think about perhaps offsetting the casters just a little bit so that you can go ahead and just give it a little bit more of a torque in that initial torque. Okay, so that's something to think about when dealing with the pallet carts such as this one here. All right, let's have a look at another example. Let's look at the cantilever example, right? This is something also that we have available, and that is the cantilever capacity. So again, we're just going to type in the known length and understand how much we can hold. So the way that works is that the HJ1 is fixed to a vertical pipe, and then the second tube is extending from that one there, and that's how much you can hold in that particular one. Okay, so for instance, in this scenario here where we see these wingspans, basically what we do is we're going to go hide these here, and we can see now the actual length of our pipe. Component attributes will give us the length, 27.375. So 27.375. Let me go back to my cantilever, and here we go, length 27.375. And now I understand that I can hold 42 pounds on that particular one. Okay, so 42 times 4, 168. Why 4? Because I think there is 4 cantilevers in this section here, right? 1, 2, 3, and 4. All right, so that means that we can hold a 168 pounds on that particular section there. All right, and if we think about what we're doing in this situation here, we can see that all of those cantilevers are being reinforced with these shorter, smaller pipes that are being added with all these connectors here. Okay, so that is going to create a really solid hold for those cantilevers. So again, something to think about when dealing with the cantilevers, and that's it. It's just about putting the known length in the capacity chart here in order to understand how much you can hold. All right, let's go to another section, or rather another example. Work table. So maybe it's a work table that you're dealing with, right? So could be heavy parts, right? It could be a component, a part that has many different components. It could be motor parts, car parts, a lot of different things that can get heavy if you're dealing with those type of parts, right? So in this case here, just an example, I have a couple axles here. Maybe they're 150 pounds each. So I just want to see how much we can hold together, okay? Again, what am I thinking about with a work table like this is we're adding diagonals so that we can support that weight, right? We don't want that weight to be moving left to right on us. So when you have a longer span, most definitely that structure is going to want to move on you. So again, think about adding a support in the middle and having angles breaking away from that to attach to the corners to distribute the weight and to hold it in place, all right? So maybe my work surface is going to require a little bit more of a strength. I beat it up a lot. So sometimes it's a good idea to think about reinforcing it with an HJ13 and adding a parallel pipe to it. So to show you what that looks like, let's go back to our section here where we can see by increasing, or rather by adding an HJ13, we increase the capacity by 66%, all right? So what does that mean to our structure? Let's go back here to determine, first of all, what length we are working with. So component attributes, and I'm just going to select here 67.875, type it in, 67.875, and we can hold 135 pounds. But if I needed to beef it up a little bit more, then I know that I can go ahead and think about adding an HJ13. So let's go back to that drawing. And what if, real quickly, we can hide all this here, and then we're just going to go ahead and add another line. So we're going to grab this one here. We're going to make a copy at 1 inch and 7/8. And then from there, let's go ahead and put a... Oh, I made a little mistake here. 1 inch and 7/8 is the HJ23. What we want is the HJ13. So that's actually 1 inch and 3/8. So let's go back to the original one, making a copy, 1 inch and 3/8. And then here we go. So basically I'll grab this one here, and let's get rid of these surfaces. And then that's it, guys. So what we did here is basically add a pipe in the middle, or rather another pipe in the front, and we're joining that with the HJ13. Okay, so basically we now have 135.57 pounds. So if we take 135.57 plus 66%, then we can now have 225 pounds resting on those two pipes there. Okay, so now we went from we went from the 135 to 225. Okay, so now by increasing, or rather by adding the HJ13 and doubling up the pipe, we can now hold a new number, which is going to be 225 pounds for this particular setup here. Okay, so not a bad idea. Okay, so think about that kind of situation when you're dealing with a work surface where, again, you're getting maybe it's getting a lot of things dropped on all the time. So it's not a bad idea to go ahead and throw a parallel, an HJ13 with another pipe, just to reinforce that particular area there. All right. So let's go to, let's have a look at this transport card. Again, if we're dealing with transport cards, it's not a bad idea to think about adding the forklift pockets to be able to also work with forklifts. Transport, we're dealing with perhaps maybe tuggers or whichever of the situations that you may be dealing with. In this case, what we're trying to emphasize more than anything is that we're going to be using a transport card for very heavy parts, very random parts, but we've emphasized the structure with the square pipe. Okay, so basically I know that at 68, let's see, so that's what, 68 15/64. So let's just call that a 68 inch. 68 inches gives us 745 pounds that I can go ahead and safely put on this particular structure here, right? So right now I know I have 1 and 2. Okay, so those are my 2 main spans that, again, like everything else, I'm re-emphasizing is that can I hold the amount of weight I need on that long span? If I can, if the answer is yes, then everything else in that structure essentially is going to be only reinforcing the initial weight of what our longest span is holding. So that means that all these other parts that we're looking at here are only going to be reinforcing everything we have already stated, all right? So that is the idea with the capacity chart, is to understand if your longest span can hold it, and then from there break it down into whether or not you need to add another section, add an angle, add a brace, and those types of setups like that, okay? So let's have a look at the last one here. Again, we're just re-emphasizing how much to put on, okay? So the amount of weight on these 2 bins, what does that mean on the particular amounts of spans? And then again, what does that mean on the particular type of casters or feet that we're using? So maybe I have a total of, let's just say that here, we're gonna say that we have 60 pounds. Let's type in 60 pounds, all right? So we're gonna say this one here can hold 60 pounds. And same thing over here, right? So we need 120 pounds. Can we hold that there? The answer would be most likely yes, right? Let's look at this. Component attributes, 42.25. Again, 42.25 tells me that I can hold 217 pounds just on one. So again, if we're dividing the structure that we're looking at into 3, we got 120 pounds and we want to divide it into 3. Okay, so 120 divided by 3 gives me 40 pounds. So basically I'm going to be distributing the amount, all of this weight, into 3 pipes, and each of them can essentially hold more or less 40 pounds. Okay, so green light go for that. If it's more weight, then maybe this is probably not going to be the good scenario where we have stem casters, so we might have to get rid of those. We may need to go ahead and maybe add the plate casters, right? So maybe now our setup is going to look a little bit different. So maybe now we need to think about adding the plate casters that are going to basically give us the ability to put more weight on the rack that we're using. Okay, so for instance here we go to casters, and then I'm just going to drag and drop one real quickly here so that we can go ahead and look at the casters that we're looking at. All right, so let's first look for the BC4, BC6, and then looking for caster wise, so something like this. Let's look at them together. So there we go. So maybe something like this is going to be the idea. Okay, so instead of having stem casters, maybe now what we need to do is add the different plate casters to be able to go ahead and now distribute the new weight that we're dealing with, but in a more appropriate way. Okay, so maybe those are fixed, or if you need the swivel, then again we just go ahead and look for the swivel casters as well. And here we can look for the swivels, and having a tough go at it here. Maybe if I open it up a little bit more, or perhaps we can just go ahead and drag and drop these in for now, just to show you guys what that is going to look like. Okay, so maybe for this one it might be a better idea to do the casters like this, so that we can go ahead and now look at that like that. Okay, so now what did I do, guys? Let's see, let's just get rid of those and we'll make a copy of these, and bring them to the opposite side. Okay, so why did I change the casters, guys? Because maybe now, instead of being 60 pounds each, maybe they're 150 pounds each. But instead of them being positioned diagonally, they're just going to be placed flat. So maybe now, again, I'm thinking about what's happening to my structure in real time. I'm beginning to now realize that I need to go ahead and put these in this scenario so that now they can be flat. Now I know that I need to extend my structure. So there we go. So we can say 5. Same thing here. We're gonna move this 5. And then same thing, right? We're just gonna essentially put everything in its new place to be able to now carry a new amount of weight. Okay, so now we're going to generate this structure just to see what it looks like in its new form. And then okay, so now we need to think about perhaps adding this one in the middle, or rather adding one there, one here, and then we can check to see if basically what we're doing now is we're going to check to see if we can figure how much we can hold on this one here, like so. Okay, so the idea is that maybe I could shorten this a little bit more just so that it actually sits right on top of the pipe. So I say yes, and then we just move this to 7/8. There we go. Okay, so now we have 200 pounds on, or rather, let's say 150 pounds on each. So now 100, which brings us to 300 pounds. We're okay here, right? We've changed the setup. We've added plate casters, so now we can take care of that weight. And then we are going to check with the component attributes here just to see how much that is, 4.25. So 44.25, 207 pounds. Again, if we're saying example, we have 300 pounds here, and we're going to divide that into 1, 2, 3, 4 pipes. Okay, so that's it. So it's going to be 300 pounds. So 300 divided by 4 gives us 75 pounds. So at 44.25, 75 is more than okay. Okay, so that's the idea when dealing with any type of structure. Okay, we're using the capacity chart. We're also going to be referencing the learning section, right? We have the capacity chart there as well, which also lets us understand how to establish your loading capacity, which is what we just did. So basically you take the longest span and you divide it by the amount that you need, if that's the case, or if you need to shorten it, add angles, bracing, and things like that. That's part of the remaining part. Okay, now from there we need to figure making sure that the structure itself is able to hold that weight, meaning is if it's on casters, you got to make sure that the casters you're using are the ones that make sense for your type of structure. Okay, so re-emphasizing, we're either going to add support in the middle, we're going to add supports angles, we're going to add a parallel joint, or excuse me, or we're going to be using the 2mm pipe. All right, so those are the main setups for the type of structures that we want to be using and doing and building. Is basically about making sure that those are going to be able to hold based on all this information that we did here. Okay, so one last look at our Flexpipe factory. So again, whether it's a supermarket rack, okay, whether it's the work table, whether it's the workstation in which perhaps you need to hang something on the roller here. Maybe it's about creating some kind of a part that is going to be hanging. It all really depends if it's a cantilever, or again, if it's the heavy duty cart. All of them are being thought in the same way, is what is my longest span? How much weight do I need to hold? And what do I do from here? Is it okay? Do I get the check, the green light with the different types of inputs and the dimensions I'm using? And if not, then do I need to shorten it? Can I shorten it? Can I make it longer? Can I add more pipes? It all really depends on what you're trying to do. But the main gist of it all is to be able to understand what is your longest span and how much that can hold. And from there, everything else is going to, again, re-emphasize what we know, which is that the longest span can hold based on this particular chart, which is going to essentially just give you the very basic number, right? Anything else, any more than that, you're going to need to have an engineer and a good amount of time to figure out what each section of every structure is going to do, okay? So from here, what we want to do is that we're now going to go and jump to the live on the floor section. So I'm going to be joined by Joe Holmes, and we're going to talk about everything we just did on the software, but now we're going to be doing this on the actual shop floor with some real structures. So again, I'll see you there for that.
Good. Right on. Okay, guys, so we're back here on the floor again. Thank you guys for hanging out for the presentation there. It's again, it's just a very simple tool. We're trying to break it down to the simplest way we can understand it. So again, first of all, let me introduce my partner in crime, Joe Holmes. He is the my guru, if you will. Everything I've learned from him. So always excited to have him around and basically learn as much as I can whenever he's around. The spans, remember, that's the main thing. Look, if we have a look here, we can see this is a 1 mil. We can see that this is moving. We can see the 2 millimeter is going to be a little bit harder to do. And then we can think about what's even going to happen when we grab the two together with the HJ13. Okay, so let's talk about this structure here. Again, this structure here, we're looking at 6 feet by 48. So we got a 72/48 here. Again, we need to figure how much we can put on each one. So just to show you an example here, this is what, about 40 pounds or so. So I'm just going to lay it down just so you guys get an understanding of what's going on. Okay, so we can see that there is a certain amount of deflection. So that's what we're trying to figure out. What is natural deflection? Will it go back to its original form, or will it be permanently damaged? So my thought process, Joe, right, is this: can I hold it on 1? Can I hold it on 2? And then why not, as a safety net, safety factor, maybe we can add a third one in the middle just to make sure that we are in the safe zone, if you will. What do you feel about that?
Yeah, pretty much. So it also depends on the depth of your cart as well, because we're talking about the longest span. But is your for floor racks, often enough we'll get like a 4x8. So basically you have 4 feet wide by 8 feet long. So you have to kick into consideration the length as well. And if it's 8 feet, you don't want to have all the weight just on the conveyors, and it's going to end up making deflection. It might pop out of the connectors or whatnot. It's no good. So then, yes, you definitely want to add a third one here, as well as when it comes to height restrictions and whatnot.
Right on. Are you guys, just want to make sure we can see this one here. We're able to show that one in the middle there. So again, right now, if we look at this, it's basically resting on the front and on the back. So imagine that in a situation where we're actually going to be using our flow racks. So now we're going to have our flow racks coming in. So they're going to be sitting on the top portion here, just real quickly, just to show you guys more or less. So now we've added a safety, because now we have this one in the middle that is making sure that these guys do not bend on each other, especially with, like Joe said, long lengths where they want to begin to kind of twist on you. Another idea, right? We have this is the union.
Yep.
So we can add this to your center, and then you can go ahead and fix directly to your pipe, and you're sure that, you know, this is basically going to be reinforcing the already what we understand, which is just to make sure that that span works. Okay. So real quickly, Joe, when we're dealing with wide structures, right, we're thinking about maybe adding a support in the middle. So a lot of people will answer, at what length do we want to think about maybe beginning to add supports in the middle?
From experience, we tend to keep any rack at a maximum of 6 feet, so 72 inches. Longer than that, you have a deflection even before you put some weight on it.
Right. Yeah, we can see that.
Very minimal, but once you start adding weight, on the chart, the Excel chart, actually, you guys will see that it'll tell you what the deflection will be in the pipe. So that's like a general rule, just for safety for everyday people, not necessarily engineers and whatnot. So that would be it. About 72 is the max.
My background, woodworking background, and that's it. I always think about studs. Like I look at the structures, like if they were houses, and I always think, if let's start to spread them out, right? So like in a span of 6 feet, depending on what you're doing, you may have to throw one. When you're at 8 foot, for sure, you're gonna want to think about dividing that into equal spaces. If important factor is if we have the ability to do so, right? Correct. If the structure allows us to do so, but perhaps maybe you have a structure in which this isn't allowed because you need access, then you need to think about other options. So again, maybe we can throw angles. Let's see here, we can have a look here. Let me know if you guys get a clear view of me here. We have an angle here. So the idea is that we want to keep this from moving left and right. Joe, if you want to go ahead and swing this over there, let's just give it a good tug there and just kind of make it go back and forth on us. So I'll hold it here, and we can see here, let's just have a look, right? So there's definitely movement going on, and that's what we're trying to avoid. That one versus what's happening here is very different. And this one here, we have those diagonal supports working from that center, throwing our weights to the corners. And if I try to do what Joe did on the other side, I have a very different output in this one here, okay? So again, it's about making sure that your pipes hold, and then what else can we do to reinforce that fact? Logic would want us to go ahead and add angles, right? Because the way we draw it, and then by the time we get it onto the shop floor, we're gonna see this is what happens. And now we can physically see what is being moved, what is being bent. So that's kind of the feedback that is very important also when you're doing your structures, is to get as much feedback as soon as possible. And that is exactly what we're trying to do. So if your operators say, hey, by the way, this structure is beginning to bend, it's beginning to move a little bit, then that's the idea, is just to make sure that we can figure out which way to do so. Joe, when do you feel is a good time to introduce or think about using a 2mm pipe?
2mm pipes are actually very practical when it comes to bases, and really bases when the flow racks are rather large. 2mm will eliminate as much deflection as possible right off the bat, increased weight. As you see here, we have a double pipe. If you have 10 levels, obviously the height becomes a factor because you don't want the rack to be too high as well. So you don't want to double your pipes. Well, 2mm is extremely practical for that.
I got you. Yeah, okay, so that's it. So let's re-emphasize what he just said. Basically, if you have too many of these, your structure is going to essentially be doubling up every time. So perhaps just 1 2mm can do what the two are doing here together, and essentially reducing your height, right? Because that's also very important, right, Joe? Is that we definitely don't want to be top heavy with any of these structures. If we're dealing with weight capacities and anything that is heavy, we want to keep those on the lower part of your structure. We're not going to be putting a 500 pounds, 600 pounds somewhere that is over our head. We definitely want to make sure that we stay within our strike zone. Remember, you can always reference the ergonomic sheets and the charts, but our strike zone, right, is where we want to keep our heavy items. In this scenario here, what we're doing is we're going to be having the heavy part arrive, and then we're going to be using the top one here as a return to keep things light on the top, okay? So 2mm, not a bad idea. Also, like you said, Joe, when you're doing your bases. So, and then the other option would be, now if 2mm is not adequate enough, then we can go ahead and now begin to talk about what is the square pipe, okay? And the square pipe here is the, let's just say, as heavy as it gets, right? So in your experience, Joe, what type of structures do we normally see being made these days with the square pipe?
More often than not, actually, it's mostly for platforms, for transporting pallets and whatnot. Another very common cart rack that we would do, once again, it's for the base uniquely, is for larger companies that travel between one factory and another. You know, like the aerospace, they have a lot of partners for finishing products. Then you have the airplanes and whatnot. Right. So if it's going in and out of trailers, you want something that's as solid as possible, because more often than not, they will be manipulated with forklifts, and forklifts, they can do a beating on a rack.
Okay, so that's true. We've had in the past, we've had to maybe think about it differently, and it's probably one of the main reasons why we've introduced the square pipe is exactly because of that. Is because there is a lot of heavy forklift usage in your area, in your factory, in your place of work, and then that's where we need to think about that as far as what Joe mentioned there, because low platform transportation, that kind of all day up and down, that would make sense for the square pipe. And then also just to mention again, we're going to be pretty soon we're going to be having the high speed 6-inch caster, and then we're also going to be introducing again the forklift pocket, I believe, that we're going to be able to slide into place in the square pipe. Okay, so again, that's great options for heavy duty. In the video we showed something that was a pallet cart. It was pushing around 1,500 pounds. Again, the square pipe itself can hold a incredible amount of weight, but you do need to think about what's happening as you begin to build from that, right? We always think about the square pipe as a base, so we want to think about platforms. When you begin to get higher and higher, you want to be really conscious about the weight, and we don't want to put anything that's really top heavy on top. You know what I mean? We want to make sure that you always keep those on the bottom. Okay. Joe, let's have a look here at this structure here, and just we can talk a little bit about the this one here. As you can see, again, we're on 6-inch casters, right? Because we do tend to move this from time to time. It doesn't get moved every day, but for every once in a while, it is going to get moved. So first thing I'm thinking about is how much is all this and what is it doing to my casters? Because with the weight of the casters, what happens is that if it's standing for a long amount of time, it's going to begin to flatten down the rubber compound of the caster.
Yeah, correct.
So would you say, Joe, that, hear me out, there's 4 casters here. We know that each one can hold 500 pounds.
Yes.
So I guess in my mind, I'm trying to think, well, if I can hold 1,500 on 3 casters, is it a good idea to think of the 4th caster as your safety caster, if you will? Do you know what I mean? Like, so we have 4, we can think of that as 25% of a safety net. So in reality, I have 1,500 pounds I can hold. My 4th caster will make sure that I am able to hold that, and that again, I can hold that weight so it doesn't flatten down my casters over time.
Yeah, pretty much. We'll see it common with everyday users, you know, for designers who don't necessarily have an engineering degree, obviously. And that's how I learned, basically. 3 casters supports the weight of the content, and your 4th cast would be the safety margin. And often enough, you won't see your rack weigh more than 500 pounds anyways. So it's kind of a nice logic to keep.
Okay, so that's good. Now, obviously, when we're dealing with length, casters is an issue too, or whether it's a stationary station as well. We got to think about maybe adding something in the middle, right? When we're dealing with that long span, about probably adding a caster in the middle just so that the weight doesn't begin to bow or bend the center of our structure, right? So what we do is we're going to be dividing the structure, putting casters in the middle. Maybe sometimes we can also add a vertical support in the middle to tie everything together in the center. Sometimes we do that with the the HJ5, where we have a middle vertical and then we have pipes coming in from 4 directions. So that's a good way to do that. Especially when we're doing maybe a pivoting turn, something that's on a tight radius. Maybe you can put a caster in the middle, and now you have your center as your pivoting point on your structure, right?
Yeah, another type of rule that we made internally is that your casters are no more than 48 inches apart, so about 4 feet. Okay. Because you got to think about the weight distribution. So even if your casters can support the weight, they're not right on the corners where all your strength is. They're a little bit more inwards.
Okay, so you can offset them?
Yeah, you can offset them. So if you have 6 feet, you know, you can bring them inside about 6 to 12 inches, and then your casters will be nice. You know, not too bad. You won't have to worry about the bending in the middle.
Okay, so
as well.
So what you're saying is, instead of having to add another one. Perhaps we can just slide these ones closer in together just to keep that 48 distance apart, 48 inches apart, and then maybe we can manage our situation with that. It really depends on what it is that you're trying to do again, right?
Exactly. If forecasters, you can safely support all the weight of the rack plus the content inside of it. Absolutely, you don't want to spend too much money either. And if ever you see that it's not up to your liking, then you can always add two more,
Okay.
and it's super easy to modify, right?
Right, exactly. That's another thing that the big issue here again is if you need to modify it, it's very simple to go ahead and add another extra part. And don't be shy. If you feel that it starts to move on you, you definitely want to make sure you address that as quickly as possible. Another thing that we're thinking about again is maybe using self taps on your structure again, just to make sure that it's another little safety factor there. It's just going to hold everything together. Okay. So a good example of that would be here. Let's look at this cart here. This is made proudly by the Flexpipe team here. So basically shipping was having an issue. They were basically having to always get down to the bottom and try to slide the straps here to get all this nice and tight for the shipping. So again, they just said part of the moonshine shop here, they came back here and just said, let's make something so that we basically are not hurting at the end of the day. And as you can see, what do we got here? We got a good 1,000 pounds, I would say, more or less here, right? So they're using those nice tight angles here just to make sure that there's no lateral movement on the tops. So those are the ends. So again, and we can see that we have self taps all around, and then we doubled up that base on this one here. We are dealing with a good amount of weight. This does get moved around, so they did throw a caster in the middle. And then anything else that we can point out from here, maybe that they do have angles basically joining from the front to the back. So there's a couple angles in there as well that can definitely keep everything together. Joe, do you want to add anything? Is there anything you see here that we should mention? You see they got the supports all throughout.
Yeah, exactly. I was going to mention that in this case here, it's a support that was added afterwards real quick on the fly. But you see here, it could have been just one pipe or simply an HJ4, which would have joined it as well. So you'd save one connector. But it's all about weight transfer. You want to make sure that it's solid. In this case, you can support a significant amount of weight. You see, like Espen mentioned, we have about 1,200 pounds, I would say. Yep. And the rack doesn't move. Like it's quite solid. You can move it by yourself, yep. Yeah, you got the bracings where needed.
So that's all very good stuff there, because again, those supports there are solid, and I think really what makes this structure be able to hold everything is those diagonals angles that they're putting across. So they're basically hooking a pipe from here, and they're connecting it all the way to the top portion of the other end on the structure here. So it's going to be nice and tight. And again, it's all about making sure that people can push this safely. This doesn't get pushed often, but it does from time to time. It's just basically more of them for them to be able to set up their packaging system here, where they're shipping the what do you call this machine here? The one that wraps around the strapper. So that's pretty much it. Just being able to have access to the straps. All right. Yeah. So, and then another little structure that I want to show. Many different examples. Again, this is just a platform for some. This is again all in-house structures that we're using here. So these are all ideas that are basically brought from the need, right? This is depending on the needs that we have. Joe, here we're using a double parallel joint, right?
Yeah,
so
here.
We're setting it up. There we go. Good idea. So here, right, what do we have here? Joe, you want to break it down for us? We have a surface, which is again doing what? It's spreading the weight, right?
Yeah, it'll help you spread the weight, but it's very useful when you have boxes and whatnot. Like if we're talking about packaging, you have a lot of these small boxes, they're about 10 inches by 12 inches. But you can also set a platform on there. Let's say you don't want the surface, it's only for larger things, and just add a couple of parallel bracings, and you wouldn't need the surface.
Okay, so we don't necessarily need a surface. Exactly, right? If you don't need a surface, get rid of it. But for what we're using here, maybe it's just the fact that it's different boxes, different items. So we just need something to be able to pull things on the fly, right, when we need to. But another option for this, I would think, would be maybe to use a square pipe, right, Joe? We could have a nice solid platform like this, depending on budget also, right? A big factor is budget wise, so But
Yeah.
if it makes sense, you should think about using maybe square pipes for low platform type of pallet cards, right?
Yeah, definitely. When you're talking about very heavy loads, it's actually safer, and price wise, it's pretty comparable to the not 2 millimeter, but the square pipes. Because if you're having a large load, then you're adding more bracings, so more pipes, more connectors. It
Okay.
adds up pretty quick. Dollars here, dollars there versus quantity. You
Okay, so
might be
that's
better off with the square pipe.
okay. So basically, you're saying that square pipe, we can probably get away with 1, 2, 3, 4, and then just one in the middle, as
Correct.
opposed to having to double everything and then maybe even continue to add more depending on what that weight is. Okay.
Yep.
Makes sense. So again, check your budget, see what's available, and see if it's possible. And then again, use the tool. You're going to use the tool to be able to see how much you really do need, how much material you really need, and to see if it's feasible or not, depending on the budget and what you're trying to do.
Yeah, exactly. And if you're using the creator, it's a bigger advantage because you can calculate the BO. Well, you can generate the BOM, and then you can easily compare the square pipe versus the regular pipes and see what actually is cheaper, what fits your specific needs.
Right on. Very, very true. Joe, we use the we use the Excel, we use the extension. But if you don't have that, you can also pull out a printout of the single point capacity chart we have online, and then you can still use the Excel regardless of if you're using the extension or not. So it's just, if you're on the spot, you're going to take a measurement of your pipe, and you're going to see how much, based on the chart, the reference, how much you can hold, and whether or not you need to modify this as well, right?
Yep.
What else can we point out here, Joe? Is there anything else that we should maybe mention? Something I left out? Something people should consider?
Well, in general, when we're using the Excel, for example, it's kind of the point. We're talking about static weight. We're not talking about throwing a box on it and
Right.
whatnot. And weight distribution is very important. If it's on casters, you absolutely want to verify if you need the diagonal bracings or not. As we demonstrated, if you have a diagonal bracing, it will help significantly, especially if it's for tall carts like this, for example, where it's very top heavy. We want to keep it bottom heavy as much as possible.
So you want a nice angle like that. Yep.
Exactly, but it's not always the case. If it has to be top heavy for X or Y reason, then so be it. Just keep in consideration that if you're pushing it, there is that lateral movement. Bracings, weight distribution, send it to as close as possible to the casters. Very important.
Okay. Let's re-emphasize that again. Let's think about ergonomics. Think about that strike zone, the heavier things where it's easily accessible, where there's the least amount of force for the operator, and then try to keep as much as you can on the top portion as light as possible. Like you said, maybe it's not always like that. Sometimes you just want to try to stay as close as you can from that strike zone. We understand that structures are different, and sometimes it is what it is. But again, if it is what it is, just make sure that you're figuring out what makes sense. And if you do something like this, and then you feel that it's still moving on you, then don't be shy, don't be afraid. Go ahead and grab some more and throw some more angles, just to make sure that, again, we're on the safe side of making structures. Again, I think that longest span is kind of the way we work here, and we've always used that kind of method, in the sense that if we can figure that this is holding it, everything else by nature we'll have to hold it all. We'll only re-emphasize again that this is holding it. Okay, so let's think about angles. Let's think about maybe adding screws wherever needed. Right. Again, if you have something that is going to be holding weight, maybe it's not a bad idea to throw some self-taps on the verticals, just to prevent this from wanting to slide on you. Okay, like Joe said, it's static, so it's not going to be us throwing something on top of a structure. Usually it's going to be on a rack. It's going to get a box that is placing on the top apart, but we're never just going to throw something and have it just bounce on top of something. Okay, so this is something else that I wanted to show you guys when we're dealing with the platforms, right? Again, so we have the I'm blanking out on the name here.
It's the corner plates for the pipes.
This is the corner plate for the pipes, and then this is the corner plate for our square pipe. So again, two different options. Weigh them out, see what your budget calls for, and then make sure that you can have a look at those two on the site just to see which one works for you. Other than that, I think if we have any questions, guys, now would be a great moment to answer any questions. If you want, you can unmute yourself and ask a question, or you can go ahead and write it down, whichever the way. Again, don't be shy. So take advantage. And then other than that, let me think. I would think in general, if you have any questions, always make sure to go ahead and just touch base with us. Again, there's web sessions, there's project managers, there's customer service, there's a million ways to go ahead and make sure that we can find an answer for you. So that's the idea here, is just to be able to make sure that everybody's building safely and confidently. It's really most importantly. So again, don't be shy. And let's just check the chat to see if there's any questions going on. Okay, all good for now. If anybody has a comment or an opinion, we're going to be sending that Excel out along with the recording right after the webinar. So as soon as the recording has been processed, we can go ahead and send you the information along with the webinar. Okay, so you're going to be able to go ahead and use that single chart capacity. Again, web sessions. We do in-house training, we do away training. So whichever way you feel comfortable, we're here to help you guys out. And again, it's just a matter of giving us a call and saying, hey, I'm trying to build this. This is more or less the weight. Is it possible? Is it not? So again, this is just another way to help you guys feel more safe, feel more confident when building. All right, good.
Wraps it
Well,
up.
all right, so if that's it for us today, then again, make sure web sessions, design team can help you with the builds. I can help you with in-house training, away training, and everything else. So let's make sure that you get a hold of us. Take care, and I'll see you guys next time. Thank you, Joe.
Yeah.